Hi and welcome to this GCSE exam walkthrough. We're looking at the AQA Higher Exam Paper 1 today. It says June 2016, but obviously it's this month, it's in May. And what we're going to be doing is going through a predicted paper. Now, by predicted paper, I don't mean to say that this is what definitely I think will be the paper they do in the exam. What I've done is just looked at all of the types of question that come up regularly. Now, AQA are a little bit less predictable than other exam boards, so use this only as part of a solution rather than just do this paper and think that you're going to be absolutely fine. Having said that, this paper will obviously help you as long as you're doing other revision as well. If you want to have a go at this paper, there is a PDF version, which I'm sure will come up on the screen now, that you can download and print out and use as much as you want. There is also an online version, this is new for this year, where you can do these questions online. It's completely free. Go to the On Maths website, and I'm sure the link is coming up now. And you can try each question. It will mark it for you, it will tell you how many marks, and like this video, it will show you exactly what grade you're on so far. So please hop to the onmaths.com website and have a look. There's loads of other stuff on there. There's a series called Demon Questions, which is all the hardest GCSE questions put together in short 3-question papers that you can have a go at. And I've started collecting all the A-star and A-grade topics into their own sort of topic buster series. So if I think at the moment there's surds, conditional probability, histograms, and a few others on there. So you can have a look at those. Everything on the site is completely free, and you can now sign up to save your scores. Again, completely free. So feel free to have a go at the free content. I can't say free enough times. Right, let's get started. So, this is question 1. If you'd like to pause the video now and have a go. Okay, so let's have a go at this question. So, a few things I noticed. There's a set of parallel lines, and we've got an isosceles triangle. I'll need both of those pieces of information. So first of all, I know that these two here, 131 degrees and this one, will add up to 180. And I know I need to add 9 to that to make it 140, and then another 40 to make it 180. So that's going to be 49 degrees. I also know this one and this one will add up to 180 because they're interior angles on parallel lines. So this one also will be 49 degrees. I know this one and this one will be equal because its bottom angles on an isosceles are equal. Now I say bottom angles, obviously the isosceles could be the other way up, but let's pretend it can't. Just be careful in the exam. The isosceles normally is this way up, but sometimes they can twist it around a little bit. Okay, I also know that 3 angles in a triangle add up to 180. So I can show the examiner this bit by doing a bit of working out. So 49 plus 49, well 50 plus 50 is 100, so therefore that's going to be 98. And I'm just showing the examiner every step. So I can't do 0 take away 8, so I borrow 1 from there, or take 1 from there. 10 take away 8 is 2. And again, I can't do 7 take away 9, so I nick that 1 there. And 17 take away 9 is going to be 8. So I know that that one here is 82. And 49 plus 82, and then take that away from 180 to find out what x is. Well, I already know that the x is going to be 49 because I've already done 49 plus 82 equals 180. So therefore x is going to be 49 degrees. And that's our answer for 3 marks. Excellent. Let's go on. So question 2, you can see if we answer this correctly, we're already on an E and nearly on a D. So if you'd like to pause the video now and have a go. Okay, so it's quite common for them to do an algebra question with multiple algebraic questions. So let's just rattle through this. Now, loads of different people do different methods for this. I do smiles and rainbows, but if you've got a different method, that's absolutely fine. You can do it with grids and all sorts. Smiles and rainbows just means you do 3 times 2x, which is going to be 3 times 2, which is 6, and then just the x. And then 3 times positive 4 is going to be 12. Now, although you can do this in any order, you could write 12 plus 6x. It's always better to put the x's first and then the numbers. Okay, this one's slightly harder this time. I've got to do a smile and rainbow, and then another smile and rainbow. Now, we're not going to do this straight into the answer thing because it says we've got to simplify as well, so we've got to do that bit as well. 2 times 3x, well, we've already done that, 6x. 2 times positive 4 is going to be 8. Now, most people will do 5 times 9, write down 45x, and then that's that. That there is not a 5. Now, I've had an argument with many a student in saying, no, Mr. Gilpin, that looks like a 5. It's not a 5. Don't ever think that's a 5. In fact, the number that is 10 away from the number 5. Yeah, okay, most of you have probably got it by now. That is a minus 5. Therefore, minus 5 times 9x is going to be negative 45x. Now, this is the one that trips people up. They think it's just going to be 5 times minus 7, which is minus 35. But we know it's minus 5 times minus 7. 2 minuses make a plus. And then 5 times 7, which is 35. So be careful with that minus there. That minus belongs to the 5 there. Okay, let's finish this off. So 6x take away 45x. I mean, it might be easier to do minus 45x plus 6x, which is going to be a negative. It's going to be negative 39x. Okay, we're just using the number line for that. And then 8 plus 35 is going to be plus 43. Now, you could write this as 43 take away 39x. Again, I like to put the x's first, and it's how the answer will look in the exam paper, in the mark scheme. So it's probably better to match what the mark scheme will look like. That's 2 marks for that. Now this one here, there's loads of different methods of doing this. I'm going to do the FOIL method, but there's really good grid methods as well that work very well. Everyone's happy with them. FOIL stands for first, and you times the 2 first ones in each bracket. So 3x times x is just going to be 3x squared. O in FOIL stands for outside, so it's this one and this one. So 3x times 2, which is going to be a positive 6x. The inside ones is the minus 2 and the x, so it's just going to be minus 2x. And the last ones are the minus 2 and 2, so that would be minus 4. Now, normally in these questions, in fact almost all the time, these two here you will be able to add them together. These two, the O and the I, are the reason it says and simplify. So our answer will be 3x squared, because there's no other x squareds. Then I've got to do plus 6x take away 2x. So that's going to be plus 4x. And then the minus 4, because there's nothing for the minus 4 to go with. And that's our full answer. Be careful with algebra. Some people feel that they need a number as an answer for them to get the correct answer. Obviously with algebra, mostly you're just writing down expressions. Right, the word factorize means to put into brackets. Now, that is a sort of a linear factorizing. We don't need 2 sets of brackets. So I'm going to just put 1 down. Now, I look at both of these and think, right, what number can I divide both of those by? Well, 15 has a 5 in it, but 9 doesn't. Looking at that, the biggest number they both have in is 3. Now looking at letters, that's got an A, or it's got an A and an A that I can divide out. So an A squared, an A times A, and that's just got an A. So I can only divide out an a from both of them. 15 divided by 3 is 5. A squared divided by a is a. Then moving on, 9 divided by 3 is 3. And then a divided by a is 1, so 3 times 1, which is just 3. If you want to check it, do smiles and rainbows or whatever method you want on that. 3a times 5a is 15a squared, well that works, and 3a times 3 is 9a. So I know that's the correct answer, so it's going to be 3a brackets 5a plus 3. Get in the habit of whenever you see the word factorise, just put a set of brackets down like I did, and then worry about it later, about how to actually put the numbers in. It's normally when you put brackets down, suddenly it triggers in your head what to do. Now this one's slightly different. Okay, obviously it's another factorised one, but we're not going to have the same type again. This time it's a quadratic. Now quadratics, you'll have a squared term, a letter term, and a number term normally. Not always, but normally. So quadratics mean I've got to have 2 sets of brackets down. And because they've been nice in this paper, well, I've been nice in this paper and just had a y squared rather than a number outside it, it's just going to be y and y as the first ones. Now I need 2 numbers that times together to make a positive 6 and add together to make a negative 5. Okay, that's what I'm looking for. So they need to add together to make a negative 5 and times together to make a positive 6. Now looking at those numbers, the only way to get a negative is if one or both of the numbers that I'm thinking of are negative. The only way to get a positive when I times them together is if they're both negative. So I know straight away that they're both going to be negative. Now 6 is quite a nice one, nice number, because there's only 2 ways to make a 6 and a 1 and a 2 and a 3. 6 and a 1 minus 6 take away 1 will give us minus 7. Well, that's not the minus 5 that's there. So the answer is going to be minus 2 and minus 3, because minus 2 take away 3 is minus 5. Let's write this neatly. It doesn't matter at all which way around you do these. The examiners will be checking both ways around equally. Okay, fantastic. So, looks like we're close to D grade already, which is a great start. Let's move on to question 3. So, if you'd like to pause the video now and have a go. Okay, let's start this. So, some teachers hate this, and some teachers don't mind it. I'm one of the teachers that don't mind doing this. I'm not going to do that one. Let's do this one. Now, some of you will know what I'm doing straight away. Some of you will not, depending on whether your teacher likes this method or not. What you can do is do a triangle for speed, distance, and time. The important thing you remember is which one goes at the top. The 2 at the bottom don't actually matter which way around they are. But whenever you're doing this, distance is always at the top. So whenever you see speed or anything talking about speed in a question, you're probably going to use this method. Now it gives us the time there, and it gives us the speed. So if I cover up distance, my cursor is not big enough, but if you cover up distance, it tells us to find distance, we do speed times time. Now the speed is 30, and the time is 4. So let's check the units, miles per hour and hours, so the units work fine because it's looking for miles as an answer. Times them together, well 3 times 4 is 12, and add the 0. So it's 120 miles. Now this one's slightly harder. It says Richard drives that amount of distance. Work out how much further Richard travelled compared to the previous day. Okay, so I need to convert from kilometres to miles, or from miles to kilometres. Now actually on this question it doesn't really matter, but because this is from an online marking one, I've decided to force you to use miles. So we're going to convert this into miles, but in the actual test paper, you could have converted this answer into kilometres. It doesn't matter. Okay, so I know that I need 560 kilometres here, and I want to work out how many miles that is. So looking at this, to get from there to there, I need to divide by 8 and then times by 5. So to get from kilometres to miles, I need to first of all divide by 8 and then I need to times by 5. Okay, so I need to work out how many 8s there are in that number, and then I need to times that by 5. So I can do the bus stop method, but some of you will look at the number and go, I already know what the number's going to be. But we'll do the bus stop method anyway. 8 into 5 don't go, 8 into 56 goes 7, and 8 into 0 goes 0. So 1 kilometre we've got, so we need to times by 5. We found out how many 8s there are in 560, and we need to times by 5. So we need to do 70 times 5, which we don't need to do long multiplication because it's just 7 times 5, which is 35, and then put a 0 on the end, so 350. So we think there's 350 miles. Now this is not the only way of doing this, but it's the simplest to explain. Let's just check to see if that's realistic. So looking at that, it's not half, it's just over half. 5 is just over half of 8, and 350 is probably around just over half of 560. So looking at the numbers, that makes sense. If I had a number of 1,000 there, then hang on, there were less miles to a kilometre, and yet it was the wrong way around or whatever. Okay, so check your answers. So I know there's 350. It says compared to the previous day. So I need to do 350. Okay, take away 120. Now I can do this in my head. You can do it in your head, but we might as well write it down. So 0 take away 0. 5 take away 2 is 3. 3 take away 1 is 2. So 230 miles. 230 miles. Just check that that makes sense. Yeah, it looks like everything's fine. 350 miles, 120 miles. How much further did he travel? So it implies that this is going to be a bigger number than the previous day, which we've got, and we've taken them away to find out how much further he travelled. Oh, there we go. So if you got that right, and you've got all the ones right so far, we are halfway into a D, which is good for question 3. Let's move on. Question 4, pause the video now and have a go. Okay, so these are always entertaining when I'm marking mocks, when I see a student just does this in them. Okay, obviously this question is part of a questionnaire. The question's not asking you to complete the questionnaire, it's saying what's wrong with the question. Now on the website there's a drop down box, we don't have that privilege, but if you look at it, it says, I think the park is really untidy, do you think it should be cleaned? And there's, I'd say the responses aren't too bad, strongly disagree, mildly agree, strongly agree. They're balanced, but the fact that it's saying I think it's really untidy, it's biased. Definitely, I would definitely use the word biased. You could use the word leading question, but bias or biased is definitely the answer they're looking for. Okay, let's move on. So if we get this right, we are on a C grade. Fantastic. So pause the video now and have a go. Okay, this looks like a horrendous question, but the important thing that you realise with this question is it's looking for you to do a two-way table. So if we get some lines down, so we've got maths, English, science, and we've got male and female. So we could have male and female going down. probably not left enough room. This is the dodgiest table I've ever drawn in my life, but it will work. So we've got got male and female. So male and female. And what I haven't done is included a total. So let's do that now. Okay. So what you want to do is have the conditions like male and female going one way, and then the subjects going the other way, but also to have totals. So maths, English, we'll just write ENG, and science SCI. So maths is the only one who has the full title, which is good. Okay, so if we have a total column for both of those, because we might need it for the question, then we can start filling it in. So there's 113 students. So if I put that down there, it's 113 in total completely. They picked one subject to attend. Okay, right, some of them, blah, blah, blah. Okay, so 64 of the students were female. So the total females is 64. Okay, 10 of the 33 students who went to English were male. So 10 of the 33 total students who went to English are male. 42 of the students went to science, so 42 of the students went to science. 13 males, so male, 13 went to maths. And what's it looking for? It's looking for females who went to science, so females who went to science. So we want this one here. Okay, let's just colour that in. You won't have that luxury in the exam because you're not allowed to use highlighters. Okay, so what will I need to work this out? Well, sometimes the best method of doing this is just fill in the ones that you know. I mean, straight away I know English. What do I need to add to 10 to get to 33? Well, it's going to be 23. So already I've got one. Looking at this, I can work out the total who went to maths. So it's going to be, let's do 33 plus 42, which is going to be 75. Then what do I add to 75 to get to 113? Well, I add 25 to get to 100, and then 13 to get to 113. So that's going to be 38. So that's going to be 38 there. Then what do I add to 13 to get to 38? So it's going to be 25. Okay, 3 plus 5 is 8, 1 plus 2 is 3, which is good. And then I can work it out here. So 25 plus 23 is going to be 48. And then 64 take away 48. So 64 take away 48. And if you want to show all your working for this, that's not a bad idea. So let's nick one off that 5. So 14 take away 8 is going to be 6. 5 take away 4 is 1. So that's going to be 16. And we could carry on. We could do the rest of it. We don't need to once we've got an answer. But if I do 113 take away 64, that's going to be 49. And if I do 49 take away 23, it's going to be 26. And if I do 26 plus 16, hopefully that equals 42, which it does. So we could have stopped when we got the answer of 16. And there's actually a couple of different ways you could have done this question, different ways around. But by completing it, we know that we've got the right answer. So what you might want to do is when you come back, when you've finished the paper, you've got some time left, come back and try and finish this off and check that all the numbers add up correctly. You can do this question without doing a two-way table, but my goodness, you look at how much easier that was to just quickly do a two-way table. And when you go back to it at the end of the paper, you can check to see whether it's correct. If you've done that all in your head or you've used a different complicated technique, then you wouldn't have been that easy to check. Right, so if we've got that right, we're on a C grade. If we've got all the questions so far correct, some of you at home will be thinking, yep, that's me, fantastic, let's move on to try and get a B grade. So, question 6, if you'd like to pause the video now and have a go. Okay, so we've got a right angle triangle. It gives us the perimeter and it's asking for the area. Okay, so a couple of things we need to do. First of all, you need to realise that with these types of question, you will be comparing algebra and real numbers. Okay, so the real number and the algebraic expression. So for the perimeter, this is quite small. For the perimeter, the real number is 84. That's what we know it is because it says it's 84. The algebra though is this plus this plus this. Okay, so the algebra is 3x plus x minus 4 plus 3x plus 4. Now we know that the real number for the perimeter and the algebra number for the perimeter are equal because they're both talking about the same perimeter. So if we put an equals there, that's absolutely fine. Now that's going to stay the same on the next line of work now, but what we're going to do on this side is collect all the like terms. So 3x plus 3x is 6, x and then plus x is 7x. So minus 4 plus 4 just cancels out, we don't have anything left. And looking at this, that looks like a horrible question, but anyway. So I'm going to divide both sides by 7 so that I get x on its own, so I can work out what x is. And 70 and 70 go 10, so 70 and 84 go 12 equals x. And we can just put x on the left hand side, which we're used to, just swap them around. So x is 12. Now it asks for the area of the triangle. Now to work out the area of a triangle, you need two of these. You need the two of these that hit each other at a right angle. We call this one the base and we call this one the height. You do not ever use this one, which is actually the hypotenuse, but you don't ever use it. So we've got the base and we've got the height. And the formula for the area of a triangle, I'll just call it A, is half times the base times the height. Now if it was a rectangle it would be just base times height, but a triangle is half a rectangle, so we have to halve it. So it's half times the base. Now the base says it's 3x, so it's 3 times 12, which is 36, times the height. Now the height says it's x minus 4, so 12 take away 4, which is 8. Now I could do 36 times 8 and then halve it, or what you can do here is just halve one of these numbers. So because 36 is bigger, I'm going to halve that, and it's going to be 18 times 8. Okay, now I know that 10 times 8 is 80 and 8 times 8 is 64, so putting those two together I get 144. So the area is going to be 144. Now you might say to me, hang on, you've worked out area and you haven't put any units down. Obviously the units, if the question's about centimetres, which it is going to be centimetres squared, but it asks you not for the area, it asks you for the value of A, and A is next to a centimetre squared. So technically speaking you don't need to put centimetre squared, but in the exam you won't lose marks for putting units. So you might as well just put it anyway, just in case it's one of the many questions that does demand units. Okay, so let's move on. Question 7, if you'd like to pause the video now and have a go. Okay, so this is mixing, well, it's mixing circles with squares, but that shouldn't be a problem for us. So we're looking for area, and any time we're involved in area and circles, obviously there's a formula we need. So let's write that down now, circle area. And to work out the area of a circle, you do pi r squared, or pi times r, which is the same thing. So we need this r. Now r is a radius, and to work out the radius, you just halve the diameter. The radius is this bit here. Now you might think, well, hang on, it's not given us a radius or a diameter. Well, actually it has given us the diameter. If this whole thing, if the height of the square is equal to the height of the circle, which it is, then this 20 is the diameter. So when you halve that, you get 10. So it's 10 centimeters the radius. So it's going to be pi times 10 squared. Okay, 10 squared is 100, and the way we write that is we write it as 100 pi. Because it's an uncalculator, we can't work out what we can, because we know that pi is 3.14, so 100 of it would be 314. But it's not asking us to, because it asks us for it in terms of pi, so we don't ever want to work out what pi is and estimate it. So it's 100 pi is the circle area. Now the square area is going to be, well, 20 times 20, because this is also going to be 20 down here, because it's a square. Okay, let's just mark that on so we're absolutely clear. So to work out the area of the square, it's going to be 20 times 20, which is 2 times 2, and then add the 2 zeros. It's going to be 400. Okay, so how would we work out what this bit is? Well, we'd do the area of the square, take away the area of the circle, and then divide it by 4. Okay, so we're working out the whole square, which is the 400 here. We're taking away this circle bit, which would leave us all 4 of these little side bits. It would leave us all 4 of these bits here. Okay, and we know that this is a quarter of that. Okay, so area of the square is 400. Take away the area of the circle and divide the full answer by 4. Now, you might say to me, well, why didn't you use the little divide sign? With fractions, it's a lot easier to show you how we're going to finish this off. This is not a fraction, and there's no divide signs in this. So clearly the question's saying, well, actually you can go a step further here. I can divide everything at the top and everything at the bottom by 4. So if I do that, I'm left with 1 there. I'm left with 100 there. And 100 divided by 4 is 25. Now anything over 1, we just get rid of the fraction. So it's going to be 100, take away 25 pi. And that's our answer. So we're very close to a B grade now. Let's see if we go over the boundary with the next question. Oh, just. So if you'd like to pause the video now and have a go. Okay, so this question, it doesn't say it anywhere, but it's all about scale factors, basically involving 2 similar triangles. By similar, we mean that it's identical triangles, just one's identically bigger than the other. Whenever you have this type of thing, you will always get 2 triangles that are similar. So we've got the little one here, and we've got the bigger one, the one that makes up the whole lot here. And those triangles are mathematically similar. Okay, they're just an enlarged version of each other. And it's difficult because they're within, this small one's within this bigger one, so it's quite hard to spot sometimes. So all we're looking at doing is working out the scale factor between the 2 lengths that we know, Okay, and to get from 5 to 15 we times by 3. So the scale factor, I'd even write down scale factor equals 3. Now this is where it gets a bit more difficult. We know that the length here is the x, that's the bit we're trying to work out, and we know when we times it by 3 we'll get the original value plus another 10. Okay, we won't get 10, we'll get the x plus the 10. Okay, this is where a lot of people sort of fall out with this question. So if our original's x, then when we times that by 3 we will get 3x. Okay, and so that will be the total length. This will be one of those x's and this will be two of them. So you could write down 2x equals 10, therefore x equals 5. Okay, it's not easy to explain, alright? So we've got a distance here and we're timesing it by 3. So if I put a notch here, okay, this one, and this one are all equal. Now if this one and this one add up to 10, then each of them must be 5, and this also is 5. Okay, logically speaking, 5 times 3, because the scale factor is 3, equals 15. This is the 10 of the 15 and this is the remaining 5. Okay, so the answer is 5 for the length of x. Okay, not easy, and some of you will still look at that and go, I'm pretty sure it's not, I'm pretty sure it's 3.13 or whatever you think the answer is. Okay, just remember that the x is both involved in the initial and the length after you've scaled it. Okay, have another look at that question later on if you struggled at it, and go back to it on the website. Okay, so we're currently at a B grade if we had 100% so far. Okay, so if you're looking for a B grade or a C grade and you've got them all right so far, you're doing well. But as we know, in the exam you will drop silly marks here and there. Even I do. Even I make mistakes on these, which is quite worrying, probably for some of you. But you know, it's human nature. So let's keep ploughing on. Make sure we guarantee ourselves a C or a B grade. So question 9. If you'd like to pause the video now and have a go. Okay, so averages question, and this one's a little bit more complicated than just a list of numbers, right? What's the average? It's missing one and it gives you a piece of information. It says the range of the cards is 6. So looking at, well, first of all we need to know what range is. Range is the biggest, take away smallest. So if we look at the biggest, which is 9, take away 6 from it, we get 3. So the missing number there will have to be 3. Let's check that. Biggest 9, take away 3, which is the smallest, equals 6. Now some people will try and be clever here and think, well hang on, okay, why don't I do the smallest, 4, plus the range, which is 6, make 10? Well, it's because the question says it has to be between 0 and 9. Okay, there's no 10 cards, so it has to be the 3. Okay, moving on to the next one. We need to know what median is. Medians, if you put them all in order of size, it will be the middle one. Okay, let's put these ones in order of size. So we've got 2, 5, 8 and 9. And it says we need the middle to be 5. So if I put a number this side, if I put another 9, then the middle will be 8. We want this one here to be the middle. Okay, so I could put a 4 in there. I could put a 3 in there. Could put another 2, I could put a 1, I could put a 0. Okay, so I could write 0 and 1, but 2, 3, 4 would work, including actually 5. If I put a 5 there, 5 would still be the median. Okay, so any number between 0 and 5, but if I put a 6 there, the 6 would slot in there and it would become the median. Okay, quite simple. So we're halfway through a B grade. If you got this correct, let's move on. And question 10, our first A grade part of the exam, part of the practice paper. So if you'd like to pause the video now and have a go. Okay, so rearranging equation question. Now I like these questions because although they're difficult, they are predictable and there's one method for doing it and you are rewarded quite well for doing them. So let's get started. Now I'm going to do lines down the side here. Okay, and this is the way I do equations, and I always put the equals in the middle. So, first step for this is to get rid of fractions. The first rule of this is if you can, get rid of fractions and get rid of brackets. I'm going to put brackets around this because this is one entity, okay? And I'm going to times both sides by that entity, y minus 3 times y minus 3. Okay, I'm showing the examiner that I'm doing it both sides. Okay, I know it's not very clear, but... So, x times y minus 3 is x y minus 3 equals, and I've got rid of this fraction now, so it's just the top bit, so 4 minus 2y. Now what did I say the rules were? The rules were always get rid of brackets and fractions, so I want to break this fraction open. So xy minus 3x. Again, this side stays the same, so 4 minus 2y. The next thing we want to do is put the y's on the same side. So I'm going to do something sneaky here. I'm going to both add 3x both sides and add 2y both sides. I'm going to do two steps in one, which is probably not a good idea, but heck, living on the edge. We're close to the exam, so why not? So we're going to add the 2y to this side, and we're going to add the 3x to this side. So we've reached the conclusion to getting the y's on the same side. We've got a problem here. We've got a y caught up, or two y's caught up in different expressions. So we can't possibly ever get y equals, you would think. The point of make y the subject of the formula is to get y equals. In fact, if you look at the answer bit, it says y equals. Okay, this is where our friend factorising comes into play. If you factorise these, let's have a look. If you factorise these two, we get a single y on the outside of the bracket, and we get x plus 2 on the inside of the bracket. So we've got rid of the bits we didn't want, and we've left one of the bits we did want. Okay, this side hasn't really done anything, it's just sat the same. Then if we divide both sides by that x plus 2, keeping them in brackets because now they're one entity. Okay, I'm going to continue this down here. We get y on its own equals 4 plus 3x, and all of that divided by, and I don't need to put them in brackets anymore because the fraction does that for us, x plus 2. So our answer is, and then let's put the x's first, 3x plus 4 over x plus 2. It's that simple. Now, yes, that looks really complicated, but the steps in doing that, they like asking this type of questions. The steps in doing it, the factorising, etc., etc., it's predictable, and you'll look at that and go, I know exactly how to do that, and you'll get the 4 marks. It's 4 marks worth getting, because if you had 100% so far and you got this one right, you would be getting an A grade. Woohoo! Let's move on to question 11 to see if we can get an A star. So, if you'd like to pause the video now and have a go. Okay, so a few things to point out first in this question. we need to know that it's a square. Why? Because it doesn't really, we can't answer this question unless we knew it was a square. If this height here is 16x, then we need to know that this width here is also going to be 16x. Okay, so that's definitely the first thing to note. We are looking for, we also need to note that m stands for midpoint, otherwise we wouldn't be able to answer that. Using that, we know that that's going to be 8x, okay, because the full one is 16, so half of it's going to be 8, and we know that that's going to be 8x. Okay. There's one side we don't know. Well, we do know it, because if the full one's 16x, and that bit we don't want is x, therefore that one's going to be 15x. Okay. So I'm just writing down things I know, things I can work out on the diagram, and that's sometimes the best way of approaching these questions, especially if you're not quite sure how to work it out. The temptation with this question is to go straight for the shaded bit. Actually, in this question, you want to work out, like we did earlier, the area of the full thing and take away the bits that we don't want. And that's the way of answering this question. You can go a little bit more direct than that, it's just not as easy. Okay, so there are three areas that we want to work out. So let's call it area 1, area 2, and area 3. So let's work out area 1. And the height is 8x. The base of that triangle is 16x. And then we need to halve it. So it's going to be half times 8x times 16x. Now, I'm going to use that half, and I'm going to halve that 16 to make that 8. So 8 times 8 is 64, and x times x is x squared. Okay, let's move on to area 2. This is going to be x times half times x times 8x. Half of 8x is 4, and x times x is x squared. Let's go into the area 3. So nice easy one here. We've got 15x and we've got 16x, so it's going to be half times 15x times 16x. Now I'm going to use the half to halve the 16 to make that 8. I know 8 times 15, well 8 times 10 is 80, so therefore 8 times 15, well, it's going to be add another 40, because 5 times 8 is 40, so that's 120. And again, x times x is x squared. Okay, so we've got each of the areas of those bits we don't want. We also need to work out the area of the full square. So we'll say square area. And this time it's just going to be 16 times 16, which is 256. You could use long multiplications, that's absolutely fine. X squared. Okay, so we need to work out, we need to do the big square area, the 256, take away all of these. So we need to add these up. Okay, so 120 plus 4 plus 64 is going to be 188x squared. So I'm just going to show the examiner that. A1 plus A2 plus A3 is 188x squared. So I want to do 256, the full square, take away the bits we don't want. Okay, I can't do 6 take away 8, so let's borrow one here, or nick one here. 16 take away 8 is 8. Can't do 4 take away 8, so just nick one there. So 14 take away 8 is 6, and 1 take away 1 is nothing. So 256 take away 188 is going to be 68. So 68x squared. Now that's not the only way of doing the question. I just find that method of doing the complete and then taking away the bits you don't want is really, really easy to do. The working out is clear for the examiner to look at, and give you full marks for, assuming I haven't made any mistakes, which I'm pretty sure I haven't. Okay, let's move on to question 12. So if you'd like to pause the video now and have a go. Okay, so this one's going to be quite a quick and easy one to go through. Rules of indices: if they have the same what we call bases, okay, which is the A's, okay, if two indices have the same base and we're timesing them, we just add the powers. Okay, it's just memory. Okay, so 3 plus 6 is 9. Okay, so it's 8 to the power of 9. A number in the inside and outside of a bracket with indices you times, so it's going to be 2 times 5, which is 10. Now with this one, people really struggle on this one, okay? Break it up into the sections, okay? I'll use the highlighter. I'm only going to look at the 44 and the 11, okay? I'm going to ignore everything else. So 44 divided by 11, we know is going to be 4. Okay, now I'm only looking at the R. We've got R, and then effectively we're dividing by R to the power of 8. Okay, because on the fraction you do top divided by bottom. Okay, R on its own has a power of 1. Divide, unlike times, which is add, divide means take away. So 1 take away 8 is minus 7. Okay, and we're just looking at the S's now. 16 and 8. So 16 take away 8 is just going to be 8. And that's our answer. Let's move on. Question 13, if you'd like to pause the video now and have a go. Okay, so we've got simultaneous equations here. Now we don't have any of the coefficients the same, so we're going to have to convert them. I'm going to convert the y's to make them the same. So this is 5 and this is 2, so I want them both to be 10. To do that, I'm going to times this equation by 2, and I'm going to times this equation by 5, because 5 times 2 is 10, and 2, which we're pretending it is, times 5 is 10. Obviously it's a minus. So when I do that, top one, I'm going to go through it. So 16x plus 10y equals, and then I'm going to times this by 2, so it's going to be 164. Times all these by 5, so it's going to be 15x, seems like it's worked out nicely, minus 10y equals minus 40. Okay, now to get rid of the 10y's, we're going to add them together, because different signs we add, d in different and the d in add. If they were the same signs, then we would subtract. Say s in same, s in subtract. Okay, so we're going to add these going downwards. Okay, so that's not such a nice one. I thought it would work out nicely. 16 plus 15 is 31x. 10y plus minus, well the minus wins, 10y is nothing, which is the whole point of this. Okay, and we've got 164 take away 40, which is 121. 124, I mean. Obviously, 4 take away 0 is 4. Okay. Now, I've got to work out how many 31s go into 124. Quite honestly, they're never ever going to give you on the calculator question what numbers that don't work so well. So if I quickly note down the 31 times table. And what's it, 124, isn't it? So it's 4. So when I divide by 31 both sides, let's just put my lines down. Okay, then I get x equals 4. Now that's what x equals. Okay, but we need to know what y equals. So if I pick one of these, I'm going to pick this second one. So 3x, 3 times x is 12. Minus 2y equals minus 8. If I add 2y both sides, 12 equals 2y minus 8. Add 8 both sides, and then divide 2 both sides, or y equals 10. And they're quite easy to check, okay, because I can just put them both back in. 8 times 4, let's say easy, 32. Okay, 5 times 10 is 50, and 32 plus 50 is 82, so that works. 3 times x is 12, take away 20 is minus 8. Okay, so you leave that exam knowing you've got full marks. Okay, let's move on. Question 14, if you'd like to pause the video now and have a go. Okay, so 3D coordinates. Well, a lot of people look at these and go, "Oh God, that's awful. It's really hard." They're not hard. It's the same as 2D coordinates. It's just you've got a z value as well as the x and the y. Now it says that we have a point A, and we've got a midpoint. So if I show we've got A, then we've got the midpoint, and then we've got B. And if I just jot the x, y, and z ones down. So, looking at the x's, at A it's 10, at the midpoint it's minus 10, so we've reached half our journey and we've gone 20. So we're going to go another 20 to get to B. Okay, and we're obviously going left. So that's going to be minus 30. Okay, looking at the y coordinates, the second one, we start at 8, we go to 4 halfway. Well, we're going to end up with 0. So we've gone 4 and then we're going to go another 4. So that's going to be 0. And here we start at 3, halfway is 5, and therefore if we've moved 2 to get from 3 to 5, we'll move another 2 to get to 7. And it's that simple. Looks really complicated, but it's that simple. Common mistake probably with this one is that they think, students think that that's B, and they've got to work out the midpoint. Okay, so actually that is the midpoint. You've got to work out coordinates of B. Okay, let's move on. Question 15. Getting close, but not quite there yet. So if you'd like to pause the video now and have a go. Okay, I do enjoy these questions. They make me feel smart. So, first of all, to simplify this, some people might go, alright, there's an x at the top, let's cross that out, and an x at the bottom, let's cross that out. It doesn't work. The reason it doesn't work is that you can't just divide something top and bottom if there's more than one term at the top or bottom. Here there's 2 terms, the x squared and the 9, or minus 9, and here there's 3 terms. Okay, the 2x squared, minus 13x, and the 21. Okay, they're 5 terms in total. So the only way we can divide everything by something is if we find something that goes into all 5 terms. Now, x squared and 9, there is nothing that goes into both of those. You could say x, well, you can't divide 9 by x. You could say 3, you can't divide x squared by 3. Okay, so the way of doing this question is by factorising. It's the second, third question so far that we've had that involved factorising. So if you don't know how to factorise, it would be a massive advantage to focus on factorising before you go through anything on algebraic fractions. So, first thing to notice is both of these are quadratics. Now you might say, well hang on, how's that a quadratic? It's not got an x term. The reason it's a quadratic is it's something called difference of 2 squareds. Difference of 2 squareds works when you've got a square take away another square number, and it's just memory. What you do is you have the square root of the first thing adding the square root of the second thing, the positive version of it, and taking it away, and that works. If you want to use FOIL on that, feel free, but it will work. Now to do the bottom, well, that's a complicated quadratic. Okay, some things we know about the quadratic already is that one of them is going to have a 2x and the other one is going to have an x. That's the only way you can get 2x squared. Okay. Something else we know about it is this one here will either be x plus 3 or x minus 3. Now you might say, well, how do you know that? I know that because you won't be able to simplify it if this one isn't either x plus 3 or x minus 3. So it already gives us a massive advantage that we know that that number there is going to be 3. Okay, we don't know whether it's going to be plus or minus yet. So we're cheating a little bit, but it's okay. We can cheat. We're allowed. Now, two numbers need times together to make 21. Well, 3 times 7, so we know that's going to be a 7 equal 21. Okay, and I know both of them will be negative actually already, because they add together to make minus 13 and they times together to make positive. So I know both of them will be negative. Okay, let's try that out with FOIL. 2x times negative 3 is going to be minus 6x. Take away 7x, okay, which is minus 13x. So that'll work. And the A grade in this question is by knowing to cross top and bottom out. So you're dividing top and bottom by x minus 3. Because we've made one big term at the top and one big term at the bottom, if we divide them both by the same thing, that absolutely is fine. We don't need the brackets to finish this off. X plus 3, 2x minus 7. And that's our answer. Let's move on. So, nice circle theorem question. So, if you'd like to pause the video now and have a go. Okay, so we've got to know all of the different circle theorems, not all of them, but a lot of them for this. First circle theorem is to know between a tangent and a radius, which this is because it goes to the centre, it's 90 degrees. This is also going to be 90 degrees. So I know that this is also a quadrilateral. It's not a cyclic quadrilateral, because for a cyclic quadrilateral all 4 sides have to be on the circle. Because it's a quadrilateral, I know it adds up to 360. So if I do 360, take away 90 will equal 180. So I know the 42 and this angle here will add together to make 180. So 180 take away 42 is going to be 138. So I know that is going to be 138 degrees. That's the first circle theorem, knowing that's 90 and that's 90. The second circle theorem says that the angle at the centre, which this is twice the angle at the circumference. In other words, this one's going to be half of that 138. So if I do 138 divided by 2, it's going to be 69 degrees. Okay, still a while to go. We're going to reuse the first circle theorem to know that this is 90. So 61 plus what is 90, or 90 take away 61, to work out this angle here is 29 degrees. And if we get this angle here, okay, angles on a circle add up to 360, so I want to do 360 take away 138, which is 222. Right, now what are we looking for? ODF, so O to D to F, so it's this one here. Now I have got a quadrilateral here, okay, it's like an arrow shaped quadrilateral. So if I take these 3 away from 360, that will get me the right answer. So I want to do 360, take away 222, take away 69, take away 29. The best way of doing that is add these together, so I can show the examiner that I'm doing it properly. Okay, so 9 plus 9 is 18, plus another 2 is going to be 20. Carry the 2. 2 plus 2 is 4, plus 2 is 6, plus 6 is 12. 2 plus 1 is 3. So it's going to be 320. And I don't need to show the examiner 360. Well, I do actually, because I need to show them working out. So 360 take away 320 equals 40. Okay, what I mean is I don't need to do this with the column method because I think it's quite easy. Now, be careful, in the online version 40 will get you full marks, but on the real version they'll want to see the working out. So every step, everything you add, subtract, etc. you need to show. They'll also need to have the reasons. So the reasons I would say is angle tangent and angle between the tangent and the radius is 90 degrees. Angles in a quadrilateral are 360, and the angle at centre is twice the angle at the circumference. Okay, and angles on a point add up to 360. Those are the four we used. Now we used a couple of them twice, okay, but they would want to see that in the working out, so make sure you write them down. Okay, let's move on. If I can. Ooh. So, question 17, if you'd like to pause the video now and have a go. Okay, so a question on surds. When it says expand this, first thing to realise is this is identical to this. Okay, and we just use FOIL on it. Okay. So the first is going to be 4. The outside ones is going to be 2 root 5, and that's how we show it. It's like algebra. We put the number before the surd. If we put the number second, it would look like root 52. The inside ones, which is 2 root 5 again. Okay, and these are plus. And then the thing you need to know about surds is when you times them by themselves, you just get the number. You get rid of the surd. So root 5 times root 5 is just 5. 4 plus 5 is 9. 2 root 5 plus 2 root 5 is 4 root 5. Now it's asked us for A and B. A will be 9, that's just the number. And B is the amount of root 5s, which is 4. Okay, let's move on. Now I'm going to show you both parts of this question. Okay, I'm going to have to write very small when I go through this one. So if you'd like to pause the video now and have a go. Okay, to try and make things easier, I'm going to enlarge this. Just note that question C says the equation equals x and solve it. Okay, so we'll worry about that in a second. So I'm going to enlarge this, and I'm just going to use this one, but we know what this question C is. So first thing is it's looking at us constructing a quadratic or drawing a quadratic curve. And it's giving us the missing numbers, or it's asking us to fill in the table. So easiest one to start off with is 0, because 0 squared is 0, take away 2 lots of 0, still 0, and it's just minus 2. Probably the 3 is easier next, so 3 squared is 9, take away 2 times 3, so take away 6. And then take away 2. So 9 take away 6 is 3, take away 2 is 1. Then the 4 squared is 16. Take away 2 lots of 4, which is take away 8. And then take away 2. So 16 take away 8 is 8, take away 2 is 6. This one's slightly harder. Okay, so minus 1 squared, minus 1 times minus 1 is positive 1, take away 2, so minus 2, so take away 2 times negative 1 is going to be a plus, and we're going to be plussing 2 lots of 1, which is 2, then take away 2. So 1 plus 2 is 3, take away 2 is 1. Now if you're not sure, normally with these there's a certain amount of symmetry. So 3 is in the middle, minus 2, 1, 1, 6, 6. Normally, if there is symmetry, apart from one of the values you've worked out, check that value, double check it, triple check it, okay? Putting these onto the graph, minus 2 goes up to 6. Now, you're going to have to forgive me because I'm not brilliant at reading these ones. So if I don't get it quite perfect, please forgive me, but it's somewhere there. Okay, and where is it? 0 minus 2 is somewhere down here. 1 minus 3 would be down here. Then we go 2 minus 2, it's about there. 3 is 1, it's about there. And then 4 is 6, which I think is roughly there. Now, I'm going to be really dodgy at drawing the curve. With your one, you want to turn the page sideways and just do one nice curve going through all of the lines. Don't join them up with straight lines, they really don't like that. They don't mind it for cumulative frequency, but they don't like it for quadratics. So, already it's terrible. Already it's terrible. Yeah, okay, that's not the best one in the world, but one thing to be careful of is this bit here. They don't want to see a flat bottom, they want to see a nice curved bottom. They want to see the bottom of the quadratic looking like that, not like I've done with a flat edge to it, okay, at the bottom, okay? So they want to see a smooth one and not a flat one, okay? So my one actually might lose me a mark, okay? One thing not to do is try and go over it again and again until you get it right. That sort of thing won't help you out. If you make a mistake, just get a rubber, rub it out, and start again. They don't want to see, I think they call it feathering, okay, where you feather the line like this. They hate seeing that and they will deduct marks for it. Okay, now I've mucked this graph up, but we'll try our best. Now, the question C across the page says, let's try and draw it. So it says, solve this. Now, it's no coincidence the graph on the left happens to be the one we've just drawn, but it says it equals x. So this is y equals x squared minus 2x minus 2, that's that bit. And we need to just draw the graph y equals x. So y equals whatever it is on this side. And I'm going to use my line tool here. And if I start it here, then I can go up to here, I think 4, 4, and let's just go the other way from here. You shouldn't really do it in 2 stages, otherwise you end up with exactly what I've got, sort of middle bit here. So that's the line y equals x. Okay, let's just draw it on here. So that's the line y equals x, and this is the line y equals x squared minus 2x minus 2. Okay, and then to find solutions, it's just where they cross over. It's that simple. So it's the x value at which they cross over. Now, to me, that looks like about, I don't know, 3.6. And this side, it looks about minus 1, 2, 3, 4, 5. Minus 0.5. Okay, so I could write down 3.6 and minus 0.5. The examiner for this type of question, where you're given a graph, is looking for you to use the graph. Okay, there's a reason you've just drawn a graph, is they want you to use it. So they're normally a little bit lenient about accuracy, but probably for this question they'll want it within a couple of small squares, sometimes even one small square either side. So you need to be quite accurate in drawing your graph. But if you draw the graph even remotely accurate, you should get the marks for writing down the x values at which the two graphs intersect. Sometimes they deduct marks if you haven't used the graphs. If you haven't used the graph to solve it, obviously you could use the quadratic formula to find solutions for those by taking away x both sides and then solving it that way. Sometimes in the question, the ones that they will deduct it for is if it says use the graph to find solutions, then you've got no chance. Okay, last question now, question 19. If you'd like to pause the video now and have a go. Okay, so quite a nice question to finish on, conditional probability. You might say, well, how do you know it's conditional and not independent? Well, it says he takes it out the wardrobe and then takes another. Well, he hasn't put it back in the wardrobe. Okay, so it's conditional. So find the probability he picks a yellow t-shirt. So let's do that bit first. He's got 5 yellow t-shirts, and he's got how many altogether? 12 altogether. So it's 5 over 12. Okay. And then wears a green t-shirt in the evening. So green, there are 7 of them. Now he's already taken one of them out. He's already taken a yellow one out. So there's 11 of them left. The word "and" in probability, you might think is a plus because it is everywhere else in maths. In probability it's times. So we need to times those. Okay. 5 times 7 is 35. And 12 times 11 is 132. Ooh. My pen's just died. So 132. 35 over 132. Normally just check if it can be cancelled down. 5 and 7 go into that. 5 and 7 don't go into that. I'm pretty sure it can't cancel down. So the answer is 35 over 132. It's quite a nice, easy one to finish off. Okay, that is us completed. Okay, thank you very much for making it this long through the video. I know it's quite a long video. There's a lot to go through. Remember, this is 70 marks out of the, compared to the 105 in the next paper. So if things don't go your way on this one, it's not all ended. However, I believe there are normally some quite nice, easy questions on the AQAs to try and help you out. Try and make sure you remember all of the definitions. For instance, the difference between equation and expression. Equation has an equal sign in. What formula is, that's when real things are used. So converting temperature from degree C to degree F, and things like that. If you please do go onto the website on maths.com. There's loads more resources on there. The Demon Question series goes through all of the harder questions. So if you've gone through this paper and you found it a bit easy, then please do go through the Demon Questions, where we've put together all of the harder exam questions. Everything on the website, the numbers change every time you do it, so you can just try it and try it and try it again. Everything on the website is also free of charge. You will not pay a penny, so please use it as much as you can. If you like this video, click subscribe and like, please. I wish you all the best of luck in your exams. Good luck, unless you're watching this for some reason after the exams. Then I hope it went well. Thank you very much. See you later.